we're going to solve this structure. So we have this weight here hanging from this point. That's the only external force that we have. And we need to know the force that we have in these cables or bars. Okay, so everything, those are concurrent forces. They all meet this, and this meet at this point, and then these three cables meet at this point. If we have equilibrium in vertical and horizontal axis, there are two equations. So if we have two equations, we have only two unknowns. So at this point B, we have the external force. This is something that we know. In this case, it's going to be 100. And we have to solve, or we have to calculate this one and that one. So we have two unknowns in this point. And this angle is 30 degrees. I'm going to do it graphically and with equations both. Okay, so we have this. I'm going to draw a line, and this is going to be 100 units. Doesn't matter what unit it is. Okay, so this is 100. And now we have another line in this direction and another line 30 degrees. We have to rotate this 30 degrees up. Okay. So that this line or this angle is going to be 30. So we can go dimension, angle dimension. So this guy, and this is 30 degrees. This is the problem now. We have 100 units going down, and then we have to calculate AB that goes left and BC that goes upwards. And why does it go upwards and not downwards? Because if this goes down, then this has to go up for sure. Okay, so now we have to analyze this. So the first equation, copy this, and that's the vertical. So in this vertical, what do we have going down? Or yeah, what goes down? 100. Anything else? Nope. And then what goes up? So that equals. And the only thing that goes up is the vertical component of this BC force. Okay, so that would be BC. And if it's a vertical component, it has to be sine 30. So that would be the vertical equation. If we do this, the vertical component going up, I'm going to create a new layer, red, and that's gonna be red. Well, I'm going to rename these to horizontal, and I'm going to create a new layer, vertical, and it's gonna be green. So what's the horizontal component? That is a red line, and the vertical component is a green line. What is the value of this vertical component? It's BC sine 30. And what's the value of the horizontal component? It's BC cosine 30. Okay. So if 100 goes down, BC sine 30 goes up. What's the horizontal equation? So horizontal, what goes leftwards is AB. What goes rightwards, it's BC cosine 30. So this is these are the equations of equilibrium. And we have two unknowns, AB and BC. We have two equations. So here, this one, it's pretty straightforward because we can calculate BC. BC equals 100 divided by sine 30. Sine. Okay, move sine 30 down. So what I want is BC equals 100 divided by sine 30. Sine 30 is 0.5, so BC equals 200. Okay, sine 30 is 0.5. What is this? Okay, so let's get used to using these kind of things. In this calculator, we have trigonometry here. We don't have anything here, so okay. So we have to do the sine of 30 equals, okay. We have to work with degrees. So we have 30, and then we have to apply the sine. It's 0.5. So it's each calculator is different, okay? But anyway, 100 divided by 0.5 is 200. This is BC. And then how much is it? AB. So AB equals BC, which is 200 times, and what is cosine 30? I think it's 0.8, but we're going to do it 30, trigonometry, cosine, it's 0.86. So this will be times 0.86. And that equals times 200. It's 173.2. Okay. So BC equals 173.2. No, sorry, this is AB equals that. BC equals 200. And AB is 173.2. Okay, so now can we do this graphically? Yes, we can. So we know that we have this line going there, and we have to create a triangle with this direction. So we have this tilted 30 degrees, and then we have this horizontal. So if we start at this point and we want to end up at this point, what we have to do, I have to copy this line to be here. I have to draw a horizontal line here. There will be an intersection, this and that. So that's gonna be BC. And this one is gonna be AB. Yep. And this is just 100. If we measure this, we go to dimension aligned. If I click here and here, this is 200. And if I click here and here, it has to be something close to 173.2. Yeah. Okay. We can use equations. We can use this method of the triangle, and the value should be almost the same. What's next? We have the following point is this one. Okay, so at this point we have BC. We know BC now, and we have to calculate CD and CE. And we have this angle here. It's 3 horizontal, 4 vertical. Okay, let's do this. So I know that this is BC, and I can copy its value too. And now there is a horizontal component, and the name of the horizontal component is CD. And then there's this component, and what we know is that it goes 3 units left, it's tiny, and 4 units up. Okay, so the angle of this is like this. Okay. This is very small, but we know that if we draw a line keeping the same proportion, so if instead of 3, I type 300, and then I go 400 up, this line connecting both, it has the same direction. You see that it matches, so I can get rid of this. Okay, so that's the polygon. If I think this is too big, I can do this, then I can trim, select this one, and delete it. Okay, and that will be CE. CE. And the angle is this 3 and. So now we have to calculate this angle. We can do it with a formula, but set line type. Line type. Okay, so now we have this BC, this CE, and CD. And we have vertical and horizontal components. Okay, so what's the vertical component of BC? We have to draw a line, and it will be like this, okay? So that will be horizontal, and that will be vertical. What's the vertical? What's the dimension of this one? So that will be 200, because BC is 200. And if it's a vertical component, that will be sine 30, because this angle, if this is 30, that angle should be 32. So let's do it again. If we dimension, angle dimension, we click here, we click there, this is 30. The same angle as this one. So this vertical component is 200 sine 30. What is this horizontal component? It will be 200 cosine 30. And now we have CE. Be careful, because here we have two horizontal components, because we have CE, we move it down. So this vertical component will be CE sine of this angle. We don't know the angle yet. Okay, so that will be the angle. But this horizontal component, it's going to be this line here. It's CE cosine that angle. Okay, so we have to add up this line and that line here. If we type or if we draw an arrow, like this, that will be a horizontal component. We have two vectors here. Okay. We have a vector that is this one. So I'm going to copy this one here. That vector is CE cosine of that angle. And then I have another vector like this, which is 200 cosine 30, because this angle is 30. Okay, so these are the two components that are going leftwards. And the only component that it's going rightwards is CD, because it's a horizontal force. Okay, so that's it. To make things seem clearer, we can calculate the angle. If we're working with a graphic, we can use dimension, angle dimension, and then we can have this angle here. It's 43.1. If we're not working with a graphic if we're not working with this software, or if we are not drawing it, and we have this 3 and 4 component, then how can we do that? We have to use the arc tangent, okay? So when we have this figure, and we know that this is 3, and this is 4. Well, we know that the tangent of this angle is 3. No, it's 4 divided by 3. Okay, so the tangent, by definition, is the vertical component divided by the horizontal component. So what is the angle? Then we have to do the arc tangent of 4 divided by 3 equals the angle. Okay, so that's the trigonometry behind this. If we have the angle, if we want to calculate the tangent, we divide the vertical component divided by the horizontal component. If we have the vertical and horizontal components and we want to calculate the angle, then we have to calculate the arc tangent of 4 divided by 3. How can we do that with the calculator? So let's figure it out. Here we have trigonometry, and okay, so each calculator is going to be different. So that's why we have to understand what we are doing. So the first thing we have to do, it's 4 divided by 3. That's the tangent of that angle, 1.3333. And then here in trigonometry, in this kind of calculator, here we have sine, cosine, tangent. But if we click here, second, we have the inverse of that function, the inverse of the sine, the inverse of the cosine, and the inverse of the tangent. This is what we call arc sine, arc cosine, and arc tangent. So we can do this. And the inverse of 1.33 will be 53.13. Okay, which is the same angle that we have here for this 53.13. So that angle is 53.13. If you haven't done this before, you have to practice so that you make sure that everything is correct. Okay, so that we know how to calculate the angle, because if we don't do that, it will be very difficult. And now, well, now we only have to create the vertical and the horizontal equations. So when it comes to the vertical, what goes up? CE sine, and now we have the angle, it's 53.13. That goes up. What goes down? That equals 200 sine 30. Sine 30. That's the vertical equilibrium. What goes up? This vertical component, and this is CE, sine of this angle, and this angle is 53.1. Now the horizontal components or horizontal equilibrium is, we have two things going leftwards. CE cosine this angle. So this is CE cosine 53.13 plus 200 cosine 30. And that equals the only thing that it's going rightwards, and it's CD. That's the other unknown that we have here, the CD. So those are the vertical and horizontal equilibrium equations. This is pretty straightforward. We can calculate CE equals 200 sine 30 divided by sine 53.3. So CE equals 200 sine 30 divided by sine 53.13. Okay. Sine 30, we know it's 0.5. So 200 times 0.5, it's 100. So CE equals 100 divided by, and now here we have to do this. I will open the parentheses because this angle is 43.13, but it's the sine. Okay, so look at this. It's 100 divided by sine 53.13. I close the parentheses and I click OK. And this is 125. Okay, so CE will be 125. CE is 125. What about this equation? So now this equation is CE, it's 125 times cosine 53. How much is it? So I can do that, 53.13. Trigonometry cosine, it's 0.6. So that will be 125 times 0.6 plus 200. Cosine 30, we know that cosine 30 is 0.86 equals CD. So CD is 125 times 0.6, sorry, 125 times 0.6 plus parentheses 200 times is 200 times 0.86. Close parentheses, click OK, and this is 247. So CD is 247. So that will be the outcome of this. We have CE 125 CD 247. So CD equals 247, CE equals 125. Can I get the same result with this? I'm sure I can. Okay, so I'm going to copy this one. This has to be 200. And it's 200 because I measured it before. So align here. This is 200, okay? And now we have to go, if we come here, then we have a horizontal component, and then we have this line, okay? So I'm going to do this horizontally. And now I'm going to copy this line here. So we close this triangle. I trim this and that. And now that will be CD. And that will be CE. I'm going to measure dimension, aligned. So this has to be something close to 247. Here, this is 248. Okay, that's fine. It's about decimals. And this has to be something very close to 125. Yeah, so this is exactly 125. So it depends on the angle and the decimals that we have taken to calculate this angle and the sine of this angle and the cosine of that angle. So that's why this can be slightly different, but that works. Okay, so we can always do this with maths using angles, sine, cosine, tangents, arctangents, or we can do this graphically. So we know that if the forces are concurrent at this point, we need to draw a polygon, and that polygon has to be closed. And if the polygon is closed, just by looking at the directions, this line should be the same value as we have calculated with the math.